Welcome to the mean and standard deviation of probability distribution. So here the idea is if we were to do the same experiment, the same trial over and over and over again and record the results, we could then take the mean of those results or take the standard deviation of those results. So if we did the same experiment or trial repeatedly, so if we did the same experiment trial repeatedly, we could record the results and take the average. And find the mean. And this is considered to be kind of what we would expect to happen, hence it also being referred to as the expected value. From a probability distribution, the formula for this, this is now theoretical. We use the symbol Greek letter mu, which looks like a fancy U or a fancy M, somewhere in between. The formula for this, we take the sum of, we take each data value and multiply by its probability. So in this case, X is a data value and P of X is its probability. We could do the same thing for standard deviation, take the standard deviation instead of taking the mean. The standard deviation, we are now working in theory. We will use the Greek letter sigma, which looks like a sideways 6. This is pronounced sigma. And to do this, we have a massive formula. We will take the square root of the sum of P of X times X minus the mean squared for each data value. So I'm just going to do an example using the same situation we were working with previously. So we're looking at the winnings from a slot machine. And we want to know what is the expected winnings and what is the standard deviation in the winnings. So the winnings is acting like my X. And then probability is my P of X. So what we are going to do for the mean is we are going to add up each data value times its probability. So we have a data value of -1, X equals 0, X equals 1, X equals 5, and X equals 100. For each of those, we will do the data value. So -1 times its probability. And then we will add, next up, data value of 0 times its probability, 0.185. Next up, add data value of 1 times its probability of 0.1. Next up, we will add data value of 5 times its probability of 0.01. And last up, we will add a data value of 100 times its probability of 0.005. So this is that formula, x times p of x. We take each data value, multiply it by its probability, and then we add those all up. So this becomes negative 0.7 plus 0 plus 0.1 plus 0.05 plus 0.5. If we add these up, that winds up being negative 0.05. So what this means is that on average, each time a person plays this slot machine, they lose 5 cents. So this is how slot machines actually are designed. They are set so that on average, the casino will win. Otherwise, why would casinos have slot machines? And the average loss for the individuals is usually somewhere under 10 cents. Overall, this one, usually people are going to lose $1 when they play, and there's a slim chance that they will win $100, but people probably see it as paying $1. It's worth it to try to win $100. Next up, if we do standard deviation, the formula for this, sigma, we will take the square root. For each data value, we will do the probability times that data value minus the mean and then square. So we had x was -1, x was 0, x was 1, x is 5, and x is 100. Probability of -1 was 0.7, so we will do 0.7 times, now we will do x minus the mean, so -1 minus -0.05, and then square. So again, this is x, this is the probability times x minus the mean squared for x equals -1. Now we will do the same thing for 0. So 0 had a probability of 0.185. Multiply that by 0 minus -0.05, and then square. So we've done -1, 0. Now we do the same thing for x equals 1. Oops. For here, we had x equals 1 was a probability of 0.1. Then we have 1 minus our mean of -0.05. Square that. Still inside our square root, we will now look at x equals 5. That had a probability of 0.01. Multiply by 5 minus our mean of -0.05 and square. And then switch to 100. That had a probability of 0.005. Then we do 100 minus -0.05 and square. So this is what the formula is telling us to do. Working through this, we have the square root of 0.7 times negative 0.95, square that, plus 0.185 times 0.05 squared, plus 0.1 times 1.05 squared, plus 0.01 times 5.05 squared, plus 0.005 times 100.05 squared. Now I'm going to go ahead and just put together all the stuff inside of the square root. And this becomes the square root of 51.0475. Once we take that square root, I get that this is approximately 7.14. So we expect a loss of about 5 cents, but the standard deviation in the winnings is just over $7. So our standard deviation is $7.14. The reason the standard deviation is so large is because we do have that $100 that was very far away from our expected value. So that's the mean and standard deviation of a probability distribution.